What is up, guys? Welcome to another epic tutorial here at Poly Academy Tutorials. Today we're going to look at depth of field and how to simulate depth of field in a 3D environment. So basically how it works is, in nature with our eyes, the further away something is, the blurrier it is, basically just because of how our eyes focus on objects that are closer towards us. And to simulate that inside cinema is not that difficult. We just need to set camera settings to the right settings, make sure we use the right render settings as well. So basically, in a camera, you get the f-stop, which is a ratio which allows the light to come through, or it's the size of the aperture inside the camera that allows light to pour through. And if you can get this right, you can get some really cool effects in cinema. So let's jump right in and see how it goes. So the first thing we want to do is get a little sphere going and throw that inside a cloner object. Let's get a good spread going. A couple of those. Let's spread these out real quick. I reckon about 2,000 and about 2,000 here. But we don't want any coming up. So we go to its spread and let's throw a random effect onto it. Spread these out a bit more. We don't want them to go up or down, so make sure that the Y position is relatively set to 0. We spread these out even more. Make sure nothing's happening. Okay, cool. So we have a nice wide spread of these balls. And if we had to render them, we would see that every single one is in perfect focus, because right now we have no camera, nothing's focused on them per se, so each of them are in perfect focus. So what we want to do is, let's first add a little texture onto them so we could see them nicely. I'm feeling dark blue today. So throw that onto our sphere. What does that look like? That's really gross. Epic. Let's add a bit of reflection, might as well. We want to click on this tab under texture, head over to Fresnel. If you don't know what that is, basically light goes through the black, through the white, depending on where black or white sits on the texture, creating matte either in the black or white, and shininess in the opposing color. That's looking a lot better now. Now let's create another object. Let's throw in a platonic. Can you see it? There it is. Let's create another contrasting color, maybe black. Black works nice. Throw that on, add some more reflection, Fresnel. Drop that down. Under color, make that dark gray. And throw that onto our platonic. So when we render this out, this is what we see so far. Everything is still in perfect clarity. Let's scale this up a bit. Epic. Okay, so now let's add in a camera. Go into our camera by clicking on this tab, making sure the tab is white. And let's try to find a nice view of these balls. What does that look like? Okay, it's starting to look better. Under our render settings, we want to make sure our renderer is set to physical, and inside physical, depth of field is turned on. We don't have to change anything else under any of the other settings for now. Let's head back into our viewfinder. Okay, under camera, select camera, go under the physical tab, and here we have f-stop. This is the ratio I was telling you about. I think regular f-stop on a DSLR is about 2. I'm not too sure, you're going to have to look that up. But for now we want to set this to about 0.8, which is ridiculously high. And also under the object of our camera, we'll scroll down, and where there's a focus object. Usually the focal distance for the camera is set to 2000 centimeters inside from the camera. So if we look at our camera, that there is about 2000 centimeters. So if we go back into our camera and throw our platonic into the focus object, it replaces the focal distance with that object. So if we look back out again, the focus is now on that object. Anything before or after will not be as focused. That's the theory behind it. So if we render this out now, we can slowly start seeing that this is not as sharp as the balls here or the platonic itself. So if we drop this f-stop even more to a ridiculously low 0.6, which is actually high as it is a ratio, render that again, and we can start to see it is looking, well, we are getting a greater depth of field going on. If you're not too convinced, zoom out again, add some more balls into our cloner, spread them out even more, about 4,000, just to get a greater spread, and let's move them out this way. Zoom back in, render it out, and now you can clearly see that these ones here are not as sharp as the ones brought by our platonic. And it's as simple as that. Thanks again for watching. If you found this useful, like the video. Any positive or negative feedback would be greatly appreciated. Thanks again for watching. See you soon.